A very good morning to you guys. Today we are going to look at binary search. Okay? Now, the first thing is, what is binary search? Now, a binary search is an efficient method of searching an ordered list. Okay, that's what we call binary search. So the list has to be ordered, all right, for us to use binary search. If it is in an ordered list, binary search will not work. Okay. Now I want to write a description of a binary search algorithm. A description of binary search algorithm. All right. Now, the first thing in binary search algorithm, that is number one, you start by setting the counter position in the middle of the list. So you start by setting the counter position in the middle of the list. Okay, this is the first step in binary search. So we are saying the counter has to be set at the middle position. All right. Number two, if the value held is a match, the search ends and the message is sent. So if the value held is a match, the search ends and the message is sent. And message is sent. Okay, so we are saying if the middle position happens to be the value we are looking for, then our search will end there and there, and to send a notification that the number is found, or whatever the case might be, it will end there. All right. Then step number three, if the value at the midpoint is less than the value to be found, if the value at the midpoint is less than the value to be found, the list is divided in two halves, comma, the list is divided in two halves. Okay, so here we're saying if the value at the midpoint is less than the value to be found, the list is divided in two halves. The two halves with the upper half and the lower half. Okay? The lower half of the list is ignored and the search keeps to the upper half. The lower half of the list is ignored and the search keeps to the upper half of the list. And the search keeps to the upper half of the list. Okay, so this is what happens. We are looking for a number, but the number that we are looking for, if you go at the mid position, that number that we get is less than the value, because we are saying if the value at the midpoint is less than the value to be found, it means the lower half haina value ya tukutsvaga. Therefore, the value that we are looking for, it will go upper half, because the value at midpoint is actually less than the number that we are looking for. Remember, this list will be an ordered list, so there is no way lower half particular value is greater than value iri kumberi kwayo. All right, so we now concentrate with the upper half. Okay, number 4, otherwise if the value at the midpoint, otherwise if the value at the midpoint is greater than the value to be found, is greater than the value to be found. Mamgaselai. Ufonenya isina moto. Mamda uti chargiswe. Alright, kana ndakunoendesa yangu kuchaja ndo yanchitora kumba. Alright, bye. Okay. Okay, so you're saying otherwise, if the value at the midpoint is greater than the value to be found, the upper half of the list is ignored. The upper half of the list is ignored. And the search keeps to the lower half of the list. And the search keeps to the lower half of the list. Okay, so you're saying we might have a case whereby the value at the midpoint is greater than the value we are looking for. It means ku upper half sisina value ya tukuchaga. Value ya tukuda ya kwanuka ku lower half. So we discard the upper half and concentrate on the lower half. Last but not least, number 5, the search moves to the midpoint of the remaining items. The search moves to the midpoint of the remaining items. Steps 2 to 4. Steps 2 to 4 continue until a match is made, or there are no more items, or there are no more items. To be found and a message is sent. Okay, so these are the steps that are involved. Now we need to consider this list of ordered numbers. Okay, we have a list of ordered numbers. So here's the position in dataset. Then we also have the data value. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Then the data values are, we have 1, 3, 4, 5, 1, 3, 4, 5, 7, 9, 11, 7, 9, 11, 14, 16. All right. Now we are looking for 11. Want to search 11. Okay. So the midpoint, how we find the midpoint here, we add the lowest number to the largest number or to the highest number, and we divide by 2. So the lowest number in our position in the data set is 0, and the largest is 8. We divide by 2, then we get 4. All right. I want you to take note. If the answer is a decimal, round it up. Okay. For example, you might have 3.5. It will become 4. Are we together? Now, here we need to check at position 4. At position 4, if you can see, there is 7. All right. 7 is less than 11. So the bottom half, including the midpoint, is discarded. So we now discard the bottom half. So we now start at 5, 6, 7, 8. Then this is 9, 11, 14, 16. So the new lower position in this case is 5. So we need to find the midpoint. Now we say 5 plus 8 over 2, then we get 6.5. This is approximately 7 if we round it off. So at position 7, as you can see, there's 14. At position 7, there's 14. So 14, as you can see, is greater than 11. So the top half of the list, including the midpoint, is discarded. So to discard the top half, including the midpoint, we are saying it's 7. So to discard this part. All right. So I left with 5 and 6. Okay, 5 and 6. Now at 5 there is 9, at 6 there is 11. So the new midpoint is now 5 plus 6 over 2. And 5 plus 6 over 2 will give us 5.5, which is approximately 6. All right. Now, at position 6, there is 11. Okay? At position 6, we have 11, which is a match, the number that we have been looking for. So the search will end there. All right? This is how it works. Now, we need to look at the binary search in pseudocode. Binary search pseudocode. Now the binary search in pseudocode is as follows. We set find to 11. We set find to 11. Then after that, we set found to false. We set found to false. Then after that, we set length to length list. We set length to length list. Just like what we've been doing with the binary search, with the linear search. And we set lower bound to 0. We set lower bound to 0, and then we set upper bound to length. We set upper bound to length, because here we are referring to the entire length. All right, so we now say while found equals to false, while found equals to false, do midpoint equals to upper bound plus lower bound divided by 2. So we are saying UB for upper bound plus LB for lower bound div 2. Okay, so if list MP for midpoint equals to find, then send found it and MP for midpoint to display. All right, and we set found to true, else if list MP for midpoint is greater than item, then set upper bound to midpoint, that's MP minus 1. Else set lower bound, that's LB, to midpoint plus 1. We end if again. We end while. So we now say if found equals to false, then send not found. Not found to display. Then we end if. Okay, so let me go through this pseudocode. So we are saying the first step, we set find to 11, since that's the number that we're looking for. We set our found to false in the event that we have not yet find 11. We set length to length list. Length list, remember, it's the total length of the list. Then, since this binary search in the upper bound and the lower bound, the lower bound is always 0 because our counter started the 0th position. Then we set upper bound to length. So upper bound in the to set to the length, meaning to say the maximum value a counter in the list. So while found equals to false, we do midpoint equals to upper bound plus lower bound divided by 2. So we are saying midpoint ya tinotanga kuwana tinoona tati upper bound plus lower bound over 2 per counter per Greek, what we call this per position in the data set inengere ma 0 1 2 3 4 here. Then we divide by 2. The value that we get to batata sapa data value kuti value iri correspond ichi. So if list midpoint equals to find, then we send the notification kuti we got the value at this position. All right, and we then set our found to true because we would have found the value that we're looking for. Else, if the list midpoint is greater than the item, like in Dopa Pandanche explain out, kana midpoint yatawana is greater than the value that we're looking for, tinengeta ku concentrate on 1/2 ndo pakutaura ne pseudocode. If list of the midpoint is greater than the item, then we set the upper bound to midpoint minus 1. Okay, else we set the lower bound to midpoint plus 1. So is kana chiseta upper bound to midpoint minus 1, it means nengeta concentrate ne, because we are saying if the list midpoint is greater than the item, ta concentrate ne lower half but not midpoint minus 1. As kana iri less than, ta concentrate ne upper bound ne, I mean the upper half, because we are setting the lower bound to midpoint plus 1. Then we end if and we end while. So if found equals to false, then to send a notification to display yekuti not found. Pane pekuti ta iterate list rese tashaya value tuku ita look for. Then we end our if. So as you can see, a binary search algorithm is much more efficient than a linear search. In an ordered list of every number from 0 to 100, a linear search in order about 99 steps to find the value 99. But a binary search would only need about 7 steps. But however, a binary search normal limitations ekuti inongoda kushanda ne list ordered. Thank you very much for watching. I hope you have enjoyed this tutorial. If you have any questions, please don't hesitate to let me know at 0784 002 002. My name is Mr. Takuzwa Kuhoni. Goodbye.